Sometimes I get up early and I'm heating a cup of coffee in the microwave, and I notice it's 13 minutes after 6, and I get a warm feeling all over. That was the number of my calculus course that I took. Did I like it? You might say I did. I had R.L. Moore's calculus class 62 years ago. Since that time, produced 29 PhD students and counting, written well over 100 research papers. Been an industrial consultant, government consultant. Now that might sound like bragging, but if I can get your attention, it's worth it. I'm willing to make the sacrifice. There's a certain, I've taught, furthermore, my teaching has virtually all been IBL from the beginning, back when it was totally illegal. And you did it at your peril. But it's not like that now. But I've noticed the IBL with gratification that it's really spread. This meeting is a test of that. But it hasn't spread anywhere nearly enough, really hardly at all. In fact, it's decreasing on the graduate level, and that's a pity. And it hasn't really reached calculus either. It's more in the middle courses. Some beginning analysis, number theory, linear algebra, it's more there. And there's a certain reason for that, I think. And it can be very clearly stated why calculus is not submitted to IBL. There's one, can you hear me okay in the back? There's one good reason why it hasn't. And that's the differentials. That's it. Now, I thought I can make Beamer slides, but I thought I was going to be sitting around a table with 6 other people. And I didn't need a Beamer for that. Just look them in the eyeballs. But a question you could ask, kind of an unkind one, what in the world is a differential? What is one? I was going to get people to try to say. Well, that's a conversation stopper, I found. They could show me how to use them and tell me how they can indoctrinate students to get a good grade on tests. But to actually define one, they say, well, that's done in differential geometry. No, it's not. They use dx's and dy's in differential geometry, and they make an accurate definition. It's perfectly good. But they don't define them in a way that's anywhere near adequate for calculus. Now, suppose your problem is to find a function f with domain all numbers, so that f prime of x is x squared over the square root of 1 plus x squared for all numbers x. Suppose that's your job. Okay, that's a standard thing in calculus, isn't it? It's a little bit involved. It's a trigonometric substitution. It's a little bit involved. You'd admit that, wouldn't you? Yeah. Well, they're just hot and cold running differentials all over. I use the plural because they're used in 4 or 5 different ways. And they morph from one mode of use to another, and they morph back. And they've never been defined. Now I want to raise the question, what are the moral and intellectual consequences of peddling something like that that's never been defined? Now you might say, well, we deal with derivatives in calculus, and maybe we don't define them, give a perfect epsilon and delta definition. Maybe because that's a hard definition. That took people like a couple thousand years to come to grips with. But we did come to grips with it, and they can be defined. But does that mean you do it in calculus? No, it depends. It's a local thing. Maybe you don't, probably not. I don't. I kind of sneak up with it, and we use approaches and such. But there's a whale of a difference between the following several things. One is that you do give a definition, an accurate definition, which would be almost always out of place the first day in class, even early in calculus class. It would be out of place. And Another is that as certainly Moore did, he got us into it gradually, and only in about March or so did he give us a definition. And that was, he said, he complimented us, that was a good class that we might be ready for. But there's another thing entirely, to use some symbols that you don't define, that have never been defined. And furthermore, they're not ever going to be defined. And what's the cost of inflicting that on people? Well, the first thing that comes to mind is Western civilization might be threatened by that. Maybe not just Western, Eastern too. It's a big crisis that so few people go into mathematics. That's probably the single biggest thing that keeps people from going into mathematics, and especially more thoughtful people. Somebody that's not thoughtful, that's just kind of a chameleon that just looks whatever color is around them, they can cope with it. They're trainable. That's about all. But a thoughtful person, confronted with that, dx this, dx y, dx that, and just manipulate them in a way that gets approval, that's not getting it for mathematics. That's not what we need. Engineering problems, scientific problems, these things are hard. They're on the research level. I've started personally an entire new field of mathematics, taking linear stuff to nonlinear. Why could I do that? I was raised on a standard of being careful about notation. Linear analysis has always had good notation. Here, T is a linear transformation. Hey, that's almost like a matrix. Hey, that really is something. Calculus, F is f of x. Oh man, give me a break. On the level of nonlinear analysis, f could be a function, and for each x, f of x could be a function, but f is not f of x. They're entirely different things. Somebody who goes around and says f is f of x, f of x, they're just out of business for the nonlinear functional analysis. Well, what difference does that make? That's just another field. No, it isn't. Applied science, it was linear for a long time. You look back in physics papers in the middle 50s, by the 50s, what do you see? We can neglect this term, we can neglect that term. What they mean is that if I don't scratch it out, I'm hosed with the problem. I can't solve it. You know, we can neglect it all. They don't have a slightest idea that they can do something like that. Well, then nonlinear analysis came along. My own view, it was probably delayed 50 years by the miserable notation. Oh, the differentials are so convenient. Okay, delaying a very important new field of mathematics 50 years and call it convenient is not my idea of utility and convenience. Well, what can we do about it? You know, there might be some people that just think it's impossible, because that is calculus. D this, D that, you know, just sort of sing it. But I'm here to say it's not, and I think a good many of you believe it's not. But some of you sort of suspect it's not, but you don't know how to do it. Okay, legacyrlmore.org/calculus. That gives you got that? Legacy R.L. Moore, no period. legacyrlmore.org/calculus. Okay, it's got the first 3/4 of a semester of my calculus course on it. I don't think it's my best copy. It's got people's name on it. I hope I'm not sued. I have somebody's name, Miss Smith, Miss this, that. When they do it, then they sign the little book, and then I update the website to put their name on it. But anyway, a D this, D that, of course, you don't see it at all. And you can do calculus. Now, there's an article in the notices by a well-known mathematician a year ago or so. pointed out that there was a big change in mathematics in the 1800s, that it got from the more manipulative side to the set-based side. It was sort of post-Cantor. Now Moore was one of the ringleaders in set-based mathematics, and his calculus course was clearly that, with never having mentioned a set of anything. If you were back to the wall, he might say collection, but a set, no, never any of that. But he had that written on his liver, and he was an extremely patient person. In my own case, this calculus class is a small class. There were 3 research mathematicians came out of it, and it was a mediocre year. John Worrell, who's here at the meeting, I don't know if he's back there or not. He was one of my classmates. And David Appling, a prolific mathematician, was there. This was just a mediocre yield for that year. Well, he gave us, he sort of complimented us. Looked like we were doing good enough that in about March, he gave us a definition of continuity. I did it. No, not a thing. That fall, I had from differential equations from H.S. Wall, the man under whom I ultimately worked. He surprised us. At the end of the first day, he said, write out a definition of continuity. That's standard Texas practice to give the problem at the end of the hour, so there can't be any discussion about it. You just have to wonder about it. Well, he gave that, write a definition of continuity. Okay, well, I went home and really tried. He asked us to hand it in the next day. That's not like Wall, to have you hand in stuff. But he asked us to hand it in. I handed mine in. He read it. Wrong. Various people's. Wrong. Well, he got to mine, picked it up. It was a mess. It was just dirty, and it was written this way and that way and upside down. It showed an anguished soul. But he stuck with it and read it and kept turning it. He said, that's right. Okay, that's when I got it, probably an hour before class. I finally got it. Well, that's 6 months. Well, I'll consider myself sort of at least average in mathematics. It took me 6 months to get it in my head. Well, that's better than the 2,000 years that it took civilization to get it. And I had an absolute genius of teaching guiding me along, even though it didn't look like that at all. Well, anyway, differentials, let us count the ways. What do you have it? You have it under the indefinite integral, the squirrely s with a dx in the bottom. Good friend from high school days. We met after both of us had calculus, and we were talking about some things, and we got to talking about an antiderivative, and he said, I wrote stuff down without any dx's and such. He said, you can't do that without it. Oh, well, he became an historian. Pretty good one. But he was mathematics and physics was his major. Well, okay, so you have it under the squiggly s without limits. You have the squiggly s with limits. You have, in this example I gave, the x squared over 1 square root of 1 plus x squared. F prime of x is that. Find f so that that's true for all x. You write x is, cosine of theta. dx is minus sine of theta, d theta. And you go through and you mess around. Some stuff cancels and you get a little thrill there. Well, then you start going back, and the theta gets replaced. You solve theta for x. Okay, got variables. Moore didn't use that word either. If he'd have been into computer science, he'd have a variable. A variable is a distinct place in the computer that gets claimed by a certain letter. But we didn't have variables. But But it's common to talk about independent variables and dependent variables. If somebody asked me, what's a variable, and held a gun to my head, I'd say, go ahead and shoot. I'm not going to spend my last minute of life babbling about something. I don't know that either. But anyway, you got independent, dependent variables. And you have the differentials. And one's kind of independent. You specify one, you get the other. But then with this antiderivative problem, the role of independent and dependent switch. There's some other transformations in between them. Maybe if you're unlucky, you'll have a dy dx times dy or something in there, and then something will kind of cancel. That's getting less fashionable. It used to be just the way it was done. Granville Smith and whoever. But if you look at this antiderivative problem critically, you'll find this morphing between the several types of differentials. Now, it's a little bit hard to talk about because there's no words to describe what's going on, because these differentials have never been defined, independent, dependent, whatever. They haven't been defined. But if you try to sort of play a game, and when differentials get mentioned in my class, it's more of a cane and a straw hat to come in and just to say, now we're going to say how other people talk. Well, so I invite you to rethink calculus in a way that differentials don't appear. And then do like you do for other IBL courses. You organize the course into a sequence of problems with the property that, if a person could work all those problems or understand them even, then they've got the course. Well, but after you've ran off the differentials, then you reorganize the course. And it just absolutely can be done. And I would expect we could double the number of mathematics majors in this country if we could get rid of them. I'd practically promise you that. I'd be gone before the people could check me out on it, but I wouldn't be surprised. Well, suppose we could double it and have them all a lot better. Would that be worth it? Maybe your calculus course, when you see that number on the microwave 60 years from now, 50, maybe you'll get a warm feeling too instead of a, Okay, hang in there.
We do have a few minutes for questions if he will answer them. He did walk away awful quickly.
This is not a question as much as it is a testimony. Before I actually met John, while I was riding in the Vietnam War teaching in high school, now I was a product of the Guilford College math program, and we were asked a lot of questions, not given a lot of answers. But summer of 1972, department head calls me in, Ed, I've been teaching the calculus. I'm going to work on a remedial course. I want you to teach it next year. Thomas may not have been Granville Smith, but I bet it did smell like it. And of course, axiomatics is where my commitment is, coming out of Guilford. And I went through the journey that John just now described. How am I going to make sense of this? I found a book that had a definition of a differential that was, contrary to what John said, a good definition. But the preconditions is that you had a derivative. Son of a gun. Well, the derivative is there now. Keep in mind, it's not foundational. It's not a foundational definition, but the differential made sense because derivative made sense. Well, son of a gun, what's the use of the differential? If in order to make it make sense, you got to have a derivative first. And that's when I scrapped the notation for the first time. And then after having John for the last 3 years of my graduate experience, there's no way it was coming back. But every question he put up there, I encountered the first time I tried to teach the calculus in trying to make sense out of what I was being asked to teach. So he's not bluffing.